Hi friends, today we will do an experiment to verify Ohm's law. So this experiment is based on activity 11.1 in CBSE class 10 science textbook. So let's get started. What is Ohm's law? Suppose that we have a conductor or we have a metallic wire like this. Let I be the current that is flowing through this wire and let V be the potential difference across the ends of this wire. Then what Ohm's law is telling is the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. So what Ohm's law is telling us is the potential difference V is directly proportional to the amount of current I flowing through the metallic wire. So we can write this in a slightly different way. So what do we have? It means that the ratio of voltage to the current, the ratio of the potential difference to the current V by I is constant for a given metal at a given temperature, and we call this constant as R. Okay, now by rearranging this equation, we can also write this relation as V equal to IR. So we have V by I to be a constant, which we called as R. Now this R is known as the resistance of this wire. So resistance is the property of a conductor to resist the flow of charges through it. And at a given temperature, the resistance is given by the ratio of potential difference across that conductor and the current that is flowing through it. Now as we know, the SI unit of this resistance is ohm. Now what happens when we plot the voltage on the y-axis and the current on the x-axis? Here we have the voltage versus current graph for a nichrome wire. So nichrome is a type of alloy made out of nickel, chromium, manganese and iron. So here we have the plot of potential difference and current for a nichrome wire. What we get is a straight line. What it means is that as the current through the wire increases, the potential difference across the wire increases linearly. This is exactly the Ohm's law, and this is illustrated by the equation that we have here, V equal to IR. So when I increases, V also increases. So in this experiment, we are going to carry out an experiment to verify this Ohm's law. So how do we do the experiment? We consider a setup like this. This is a circuit diagram that we have. So we essentially change the number of batteries here, and we will measure the current flowing through this wire and the potential difference across this wire for different number of batteries here. So what do? We start with just one cell in the circuit. That means we connect this wire like this, and then we note down the current through the nichrome wire, and we measure the current using this ammeter A that we connect in series with this wire. We also note down the voltage difference across the nichrome wire, or we note down the potential difference across these terminals X and Y by connecting a voltmeter here as shown here. So we first do this for one cell, and then what do? We repeat the experiment for 2 cells, 3 cells and 4 cells, and once we do that, we will be getting the voltage across these terminals X and Y and the corresponding value of current flowing through it. Once we have that, we will find the ratio of voltage and current, and we will plot a graph of voltage versus current. This is the experiment. Now to do this experiment, we need the following things. We need batteries. So in this case, we will be using 4 batteries each of 1.5 volt. This is the usually available battery in the market, like the one that we see here. This is the battery. Then for the wire, in this experiment, we consider a nichrome wire of 1 meter length. So this is the wire that we have. This is a nichrome wire of 1 meter length. As we see here, this terminal X is here, terminal Y is here, the switch K is here, and this wire is like this. Now we need connecting wires to connect these things here, and then we need an ammeter to measure the current and a voltmeter to measure the potential difference. Now if we don't have an ammeter, we can also use another device known as a multimeter. So multimeter is a device that can measure both current and voltage when we appropriately set the things. So in this experiment, we use a multimeter to measure the voltage here and a multimeter to measure the current here. So let us start the experiment. First, we have only one battery in the circuit. We have only one battery here. Now what do? We measure the current and voltage. So we will turn it on. We have turned on the circuit, and as we can see here, the current flowing through the nichrome wire is 0.28 ampere and the potential difference across the nichrome wire is 1.24 volt. So we will note these values here. The current is 0.28 ampere and the potential difference is 1.24 volt. Now once we make the readings, it is important to turn this network off. So once we note this down, we will turn on the circuit. So whenever in any electric circuit, once we are done with making the measurement, it is always important to turn the circuit off by switching the key off. Okay, so now we have the measurements for a single battery. Now we do the same thing for 2 batteries, 3 batteries and 4 batteries. So now let's say we have 2 batteries like this. We connect 2 batteries in series like this as shown here. We do the same thing. We will turn on the circuit and we will measure the current and voltage. So in this case, we have a current of 0.5 ampere and a voltage of 2.2 volt. So we will enter the values here. Next, we will move on to a case with 3 batteries. So now we have 3 batteries here again in series. We will turn the network on and see the values. Okay, so as we can see here, the current flowing through the nichrome wire is 0.65 amperes and the voltage difference across the potential difference across the nichrome wire is 2.9 volt. So we will mark these values here, and finally we consider a setup with 4 batteries. Now we have 4 batteries here. As before, we will turn it on, and as we can see here, the current flowing through the nichrome wire is 0.78 amperes and the potential difference across nichrome wire is 3.47 volt. We will mark the values here. Okay, so now we are done with the experiment. What do we do now is we will try to analyze these values. So we have these values here. What we do is we will find the ratio of potential difference to the current flowing through it. So we do this V by I. So what we do is like we will divide 1.24 by 0.28 and mark it here. So as we can see here, we have 1.24 by 0.28 which is 4.43, 2.2 by 0.5 is 4.4, 2.9 by 0.65 is 4.46 and 3.47 by 0.78 is 4.45. Now this ratio we have found out and we can see that it is almost a constant. It is more or less a constant. It's like almost it's like always 4.4. Now we will plot a graph with potential difference on the y-axis and the current on the x-axis. So as we can see here, we have the point. So here for example, here the point 0.28 comma 1.24 is this one. The x-axis value is 0.28 and the y-axis value is 1.24. Similarly for this point, the x-axis value is 0.5 and the y-axis value is 2.2. Similarly we do for the other 2 points also. So we plot these 4 points on the graph like this. Now we can extend this graph. What we can see is that the graph of potential difference versus current is a straight line that passes through the origin. So exactly like what we have seen in the beginning. So this is precisely what Ohm's law is stating. So we have the relation V equal to IR. When I increases, V also increases. As you can see here, when the current increase, the voltage also increase. And the relation between current and voltage is that of a straight line as indicated by this equation here. Moreover, when the current is 0, the voltage also is 0 as we can see by extending this line here. Also, if we see here, the ratio of voltage to current is a constant which we have seen as the resistance of the wire that we have there. So in this case, we can see that the ratio is almost 4.4 and therefore the resistance of the considered wire is 4.4 ohms. So to conclude, in this experiment, we have verified the Ohm's law. So what did we do? We consider a nichrome wire of 1 meter length and we measure the current flowing through it and the potential difference across it by varying the number of cells in the circuit. We plotted the value of voltage as current and we found out to be a straight line as per Ohm's law. So to conclude, today we have verified the Ohm's law by carrying out an experiment. This concludes the presentation. Thank you very much for listening.